In this video, we're going to discuss optimization. Now, optimization has been a topic, that's been in our community for a long time. It's something that Lee has focused on this year, uh, along with bug fixes and other things. Optimization was kind of the big ticket. And we talked about it and he improvements have been made, but I'm not sure that it's really been explained just what these optimization pieces are or how they work. And also, I thought it'd be a good opportunity to talk about what else you could do, because the fact is that no engine can optimize your game for you. That's just not possible. Doesn't matter if you're talking about Unity or Unreal or Godot or whatever it is, no engine can optimize your game for you, period. You have to do it. You are the developer. It is up to you to pay attention to the details that matter when it comes to optimization, because no matter what the engine provides for you, if you don't take those steps, your game could still suffer performance issues. Okay, so with that said, there's a lot that's been done to GameGuru Max to help you with that. Right, so that's assistance, but it's not everything. You can't just be like, tick the box, it's optimized. Great. Doesn't work that way, but there is a lot of tick boxes here, and we'll go through each one of them, and it's going to help you out a lot. And then I'll talk about some of the other things that you could do as the developer and pay attention to just bring it that next level. So let's just step through the graphics and performance section. So you'll notice that I have clicked this little world icon, and that's opened up the environmental effects section. And then here, there's a new section called graphics and performance. So that's where the optimization piece has been added. Now there's a drop down here that is sort of a preset. So if I choose low, then all these checkboxes, or practically all these checkboxes, are checked. If I choose high, then a couple of them get unchecked. So you could just, choose one of those depending on your game, and it makes it kind of simple. Or you can customize your settings to the way you want it to work for your game. Obviously, the highest level is for the best quality. So that means your fidelity and everything will be higher, but that's at a cost of performance because you're asking more from the engine and from the computer to do more calculations. And so, with more work comes more strain on the system. You could do low, and that's best performance, but again, fidelity is going to suffer a little bit because it's going to be, taking into account the fewer shadows or whatever. We'll go through all those settings. So we have the first tick box that says lower animations and Lewis Spade. Now, if you were to cursor over this, it tells you just what it does. It says it will lower the updating of animation and Lua to 30 frames per second for increased speed when using mini animations. Okay, so that means you're capped at 30 frames per second if you tick that box. So as you see, if we choose low, it's ticked. If we choose high, it's not ticked. It kind of depends on what you're doing. If you don't have a bunch of Lua and animation in your scene, there's really no reason to tick that box. There's also delayed shadows, and again, if we cursor over here, it'll tell you just what it does. It makes fewer cascade shadow updates and increases your FPS. Let's just think that through for a second. If we're in a hallway, for example, and there's a bunch of different lights, at different angles, and as we move through that hallway, the shadows move with us, right? Because our perspective is changing. When we do that, there's basically a cascading of that shadow effect so that it sort of moves with you, gives you the illusion of movement. Uh, it'll do fewer of those. And again, fewer calculations, better performance, but at a cost of fidelity, right? You don't get as many shadows, it doesn't look as cool. So again, up to you, kind of depends on your lighting scenario. It's very, very specific to your game. That's why no engine can do it for you. So next one is occlusion culling. What is that? Well, it tells you. It says it will cull objects behind other objects for less draw calls. So what does that mean, cull? Well, I mean, it basically means that if there's an object, let's say behind these buildings, we couldn't see it from our perspective. So there's really no reason to draw it. There's no reason to render it. So it's just not going to. So it's culling it from the scene temporarily. Now, once we are in a place where we could potentially see it, then it'll be rendered, but only then. And it's just fewer calculations in the meantime. So we could tick this box here, and that'll allow us to debug. So pay attention to what it's doing down here. If I untick that box, see a lot of these settings down here, which we'll go through in a second, go away. If I tick it, then I get more. So it's really just showing you more information about the culling experience so that you can really fine tune things. But I don't see most of us really using that. I think that's more, it's a nice to have for people that are especially using like custom models and they're trying to work out specific things, but I don't see most of us using it. You probably just leave that unticked. Same thing with the debug bounding box. If we tick that box and we have the debug on, you have to have both, then you can see the bounding box for all the objects. And that's particularly useful in scenarios like this, where you have a whole bunch of objects nearby each other, and you want to see where those bounding boxes are overlapping. Again, really just, something I think would be useful for somebody like a 3D modeler, not necessarily something that the average Joe is going to use. So we can untick those boxes. Just going to go back to low, because there's a tick box that shows up whenever you do custom or low that doesn't show up for highest, and that is laptop. So let me go back to low. There's laptop. And if we cursor over the top of that, it says we'll make even fewer cascading shadow updates and increase your FPS. So it's assuming that if you're, operating on a laptop, then it's going to have a lesser amount of power, a lesser graphics card, lesser processor. And so it's taking that into account. So this tick box is in line with the shadows. It's just even fewer shadows, and then the debug has to do with the culling, the occlusion culling. So these things are in line on purpose. And I wanted to point out that if you choose highest, then it doesn't take that into consideration at all. It just goes away. So if you're missing that, that's why. Okay. Then we have the terrain chunk calling. Now this is where we start to lose our tooltips, right? When we cursor over, we don't get any more information. So I've had to research this myself. Now, terrain chunk culling is essentially what it says. If we think about an outdoor scene where there's a lot of mountains and trees and lakes and whatever, and it's in the distance, right? Some of our maps are huge, but we're not going to see all of that uh, within our view range, right? It's as we climb over the mountain and so forth that we see the valley on the other side or so forth. And if that's the case, then it's just going to not render any of the terrain chunks that it doesn't have to, that you're not going to see anyways. There's no point. So another one of those check boxes that you could just set it and forget it. Then we have point shadow culling and spot shadow culling. These are basically the same. It's about shadow culling, right? About removing shadows we don't need. But it's giving you the flexibility to choose between point and spot lighting. And again, this is very specific to your game, but ultimately, if you don't know what the difference is, here's a spotlight. I'm sorry, here's a point light rather. So that's a point light, and we can turn it into a spotlight, right? So if you check both, it applies to both. If you check one, it applies only to only the one you checked. And it applies to the shadows casted by this light. Now, you might not choose to cast shadows, in which case it wouldn't matter, right? So you can untick that and it won't cast any shadows at all, and therefore there's nothing to cull. But if you are casting shadows, then take that into consideration. And bear in mind, you don't want a whole lot of lights, right? I think that's something that I made the mistake of doing early on as well, is adding a whole lot of lights, a lot of little point lights along the way. And it's just not necessary because you're only going to see so many of them anyways. And you can broaden the range, the light distance, to cover a bigger area. So you don't really need individual lights at every little spot. But something I've learned along the way. So the object culling. So that might be confusing because we've talked about occlusion culling, which is culling objects that are behind other objects that we wouldn't be able to see anyways. So what's object culling? Object culling has to do with the distance you are from that object, right? So if as we move away from an object, it gets smaller and smaller and smaller, right? And so as we do that, eventually, if we get far enough away, we won't see it at all. It'll just go away. So if there's an object out in the distance that's so small you're not going to see it anyways, it just doesn't render it. There's no point in doing that, right? Same thing with animations. We have animations over here. I actually just reused a scene that I made for some other behavior. And you can see, if you look closely, these guys are animated. So if I were playing this, if there were animations happening over there, but I'm up here on this roof, I'm not going to see them. So it doesn't bother rendering the animations because there's no point. I'm not going to see them. So it's all just saving performance, saving memory, saving, the need to do those calculations for nobody. So I would encourage you to, make sure that you have these ticked the way that you need them for your game. Again, I can't really advise what the right settings are for you. You play around with it, see what it does. And you can tell just what it does by looking at these numbers. So take a look at this, for example. We're on custom, right? We've got the laptop ticked, so let's untick that. So, because we're not going to have that most of the time. So this is the total number of objects, and then the frustum rather, and apparent cold. So out of all the objects that we have, these are the number of objects that are cold because we're not looking at them. There's no reason to render them, right? So what is frustum? Frustum is the viewport, what we see in our screen. So that's, and then the parent is, even if we were to technically be able to see it in our screen, if we wouldn't see it because it's behind another object, then it's not apparent. So we wouldn't be able to see it. So it's just kind of combining the two things. Then we have the occlusion terrain chunks that are called. And so it's giving you, what's happening at any given time. If we change that to highest, we see different numbers. So you play around with this and see what it's doing and kind of how it works. You can also, as you move, you'll see different numbers happening because, it changes with what it sees. So it's very dynamic. The other thing you'll see change is this little slider. So it says max apparent size will call objects when they get smaller on the screen. So we talked about that before. It's about distance and the apparent size of it. So if we choose highest, then it sets it to 0.08. If we set it to lowest, then it sets to 1. So play around with that slider, see what looks and feels right for you. But that's what the optimization effort was all about, was adding these features into Max so that you had more control about what Max did for you. And I think it's done an amazing job at adding to the performance. But we're not done. There's more to do. As developers, like I said early on, there's only so much that the system can do for you. Even having these tick boxes checked from by default, and kind of, even if you never knew they existed, they're just working for you. That's great. But if you're using, high poly models and you're using polygon collision on everything, it's still going to suffer. So what do I mean by all that? Let's take a look at this scene. I chose this scene very specifically for a very specific reason. You can see that there is a wall that surrounds the play area. So I wouldn't be outside of this wall. You can see the scene doesn't even have any texture on the ground outside of that wall. So I'm not meant to be outside of that wall. That means anything outside of this wall, I'm not meant to interact with any for any reason. So that means everything outside of this wall should not have a collision. So let's just take a look at it. If we click on this and we go in here, it's a static model, but it's got a collision shape of polygon. Doesn't need that. It has that because it's defaulted that way, the model itself, but you can change it, right? So if you're using a model and you're not going to interact with it, it's just scenery, turn off the collision, right? And we do that for every object that we're not going to collide with. So like these upper objects up here have no collision because you're probably not going to collide with them. So low poly assets are as low as you can within reason, right? I mean, what constitutes a low poly asset? It really just depends on the asset and stuff, but you just want to keep that as low as possible because every polygon is a calculation. So keep that low. The collision thing really matters, right? Anything you're not going to interact with doesn't need collision. Just turn that off. That's one less thing it has to worry about. Then there's audio optimization, right? So if we're using audio in our level, we should be making sure that the compression is, a high compression format. So like .ogg, .wav are good examples. I'm not an audio expert, but this is what I read. So I'm going with that. 3D sounds require mono sounds, right? And so if you have, let's suppose we have an audio behavior on something, and as we get closer to it, it gets louder, and as we get far away from it, it gets quieter. That's a 3D sound. And that requires a mono sound. If we were to use a stereo sound, it wouldn't matter what the distance is, we'd hear it all the time everywhere we go. So use your mono sounds, and that'll control what you hear at any given time. Because if you're trying to play a lot of different audio from different sources and they're all kind of overlapping, that again, that's just more it's got to do. So control how the audio in your game is played and what the player hears at any given time, and don't overlap too much because it's just more it has to do. One other tip I would mention is testing, right? So you're going to be doing, hopefully, going to be doing some play testing on your game to make sure that things work right and that the feels right, it's fun, and so on. I would encourage you to shop that early demo version of your game out to as many people as you can, not only for the feedback that you're going to get, right, but also ask them what their hardware is like. Write that down. Keep track of who has, the good, really good high end systems, and who has maybe the lower end systems, especially compared to your own system, because you're going to want to know, how does this game perform on a high end system versus a low end system. And unless you have all these different systems that you can play test on each one, you're not going to know that. So you're really going to want to kind of shop around and get a wide spectrum of machines playing your game, so you really know, what's working and what's not working for everybody. Now, I would be remiss if I did not mention LOD. And I know that if I didn't, somebody would chime up in the comments saying, what about LOD? When are we getting LOD? So what is LOD? What am I talking about? Level of detail. So what that means is we can reduce the number of polygons on an object, and that will decrease the level of detail on that object. But that means that the object won't be as defined and crisp and clear and detailed as it would be at a higher polygon count. And that's useful when you have a object that's getting further away from you. It doesn't need to retain that high level of detail as it travels away from you, or if you travel away from it, it could reduce in quality as it gets further, because you're not going to see it anyways, right? That's level of detail. That feature, as of the recording of this video, does not currently exist in Max. Now you can get a supplemental program from Prebin. I'll leave a link to his Patreon page down below, so you can subscribe to that if you want to. That's entirely optional, and then that would give you your LOD settings to kind of optimize even further. But that's it. That's the optimization that I wanted to cover in today's video. I hope you found it helpful and it makes your games even better. If you enjoyed the video, or if you learned anything new, please be sure to click the like button, just like always. If you're new here, or if you just haven't subscribed yet, we'd love to have you stick around and see what the engine is all about. And if you'd like a notification for whenever new videos are posted, just click the bell icon, and that'll let you know when a new video is ready. Thanks so much for watching all the way through. I always appreciate it, and I'll see you in the next one. Bye for now. Hey, don't forget, there's a written guide for every behavior, including ones I haven't yet covered on this channel. And if you want to learn some more, why don't you check out this video next.